Well, hello friends. In this lesson, we're going to learn about something called stoichiometry. Big word in chemistry problem solving, okay? So definitely something that you're going to do a lot of throughout the rest of the course. I think we should start by reviewing what a balanced equation actually tells us in quantitative terms. You'll recall that we balanced equations by putting numbers that we called coefficients prior to the formula for each substance in the equation, and those coefficients represent a number of particles. In this case, they're all molecules because these are all covalently bonded compounds. So in this case, I could say the number of molecules of each substance that would be reacting or being formed. However, we can easily scale molecules up to moles, and that is generally how we express the meaning of the coefficients. Coefficients represent the number of moles of CH4, oxygen, carbon dioxide, water that are participating in the given balanced equation. Oh, hey, you know what I just totally discovered? And that is this equation is incorrectly balanced. So I'm going to jump in here and I'm going to cross out this 3 and I'm going to make it a 2 because I can't change the typing. I brought this in from another platform, so I can't change the typing. But anyway, what I've said previously is still true. Sorry about that. Now these these molar relationships can be expressed as ratios. So I'm going to show you some of the possible ratios that can be written given the equation you just looked at. So you'll notice that I have set up 4 possible ratios, and there are others. A ratio can be made by putting any reactant or product divided by any other reactant or product to express a numerical relationship between them, okay? And these are going to be used as conversion factors to calculate how much of one substance reacts with or is formed from how much of another. Likewise here, I have just fixed the 2's in my ratios. My deepest apologies, guys. Sorry. You can tell I've been on vacation for almost 2 weeks. Okay, so I have corrected my equation yet again. And I'm going to show you how these conversion factors can be used to answer a question. So let's say you were asked, what if 0.156 moles of CH4, the name of that compound is methane, what if 0.156 moles of methane reacts? Okay, you could then determine from that given prompt, that start, how much oxygen would be needed and how much CO2 would be made and how much water would be made by doing 3 separate calculations. So I have set each of them up. You will notice that in each there is a cancellation of moles CH4, as we have seen in conversion factors in the past. And so we can calculate the amounts. You notice that I'm saying this oxygen is needed because it is. I won't get the product if I don't also use the needed oxygen to make those products. I can say that the products are made, formed, produced, yielded. Okay, different words can be used, but we're just saying how much product would be made. So here we are. I have on this screen 3 questions based still on the same equation. What I'd like you to do is to pause the video and set up the conversions. Write out your steps. Please don't just grab your calculator. I will always need to see your setup for credit for your work. So you need to always set things up as usual. Even if the ratio is 1-to-1, it is customary to write it in as a 1-to-1 ratio. Okay, so that the cancellation of the units is evident. I know there's sometimes a tendency to want to take a shortcut. I would advise against that. Okay, so go ahead and pause. So here you can see my setups for these calculations. Each of the first require only one step because the unit cancellation is moles to moles. And so I set the ratios up so that the units cancel. The last one has a preliminary step required, which is grams to moles, followed by the ratio. So it may be necessary, if you're given information in different units, it may be necessary to convert those units before you set up the ratio. There you go. A little note here, all of these scenarios assume that there's enough reactant, of the other reactant, available to complete. Okay, so if one of the reactants is not mentioned, assume there's plenty of it. So here we go, another balanced, actually not a balanced equation, another given equation and a question. So the first thing you will do is balance the equation, and then you will use the conversions and the mole ratios to answer the given question. So write this out in your notebook, pause the video, and then start it up in a few minutes when you have finished. So let me talk you through the first three things, because we have done these before. Number one, balance the equation. Number two, because you're given grams, you need to do the first step, which is a grams to mole conversion, and the second step is to apply your mole ratio. However, I'm asking you for mass of KBr. So there's actually one additional step on this, which is now to do a step to convert, to convert the moles back to grams. And so I'm going to add another step here. So let's just take a look at what the units are doing. The first thing we're doing is getting rid of grams of lead bromide, converting it to moles. The second conversion is the moles of lead bromide to moles of KBr. And the final step is moles of KBr to grams of KBr. So the answer to this question is 6.49 grams of KBr. So this problem took a max of 3 steps after you balance the equation. So here's a list of the steps that you would do to solve a stoichiometry problem. I would write these in your notebook and keep them handy for reference. Okay, eventually you won't need them, but that may not be the case for a few days. Okay, so you're going to balance the equation, find moles of something given. Sometimes it's given in moles, in which case you're already done with step 2. If it's given in grams, you have to convert it to moles. Third step, use the ratio. And fourth step, convert the final answer if you need to. You may not need to do step 4. Okay, one last question. I'd like you to apply the steps you just wrote in your notebook to this particular problem. Pause and restart when you're done, and I'll show you my solution to this. So here I've broken down each of the steps that we're going to do to get the answer we're looking for. In this case, I threw you a bit of a curveball because I gave you kilograms. So you had to convert kilograms to grams prior to grams to moles. Then we used the ratio, then we did moles to grams. And if we check the units here, everything should cancel. Kilograms cancels kilograms, grams cancels grams, moles of C6H12 with moles of C6H12, moles of CO2, and the only unit left in my problem is grams of CO2. So we calculate it out. 1.02 times 10 to the 4th grams, or if you wish, convert it to kilograms. Either answer is acceptable because they are both units of mass. Okay, good work. I will see you in class.